Now the next example of the second order reaction is the reaction in between the potassium persulfate and potassium iodide. The reaction we can represent like this. Plus potassium iodide, potassium persulfate plus potassium iodide, it gives potassium sulfate plus iodine. So the reaction takes place in between potassium persulfate and potassium iodide, in which the products are potassium sulfate and iodine. The rate of this reaction we can study by measuring the volume of iodine liberated at the different time interval by titrating the fixed volume of the reaction mixture with the standard hypo solution. Now this reaction is the second order reaction because the rate of this reaction depends upon the concentration of both the reactant, potassium persulfate as well as the potassium iodide, and hence this one is the second order reaction. The rate of this reaction we can study with the help of measuring the amount of iodine liberated at the different time interval. The amount of iodine liberated as well as the concentration of iodine liberated we can find out easily by titrating the fixed volume of the reaction mixture with the standard hypo solution, and we get the volume of hypo solution required for the reaction or the titration with the fixed volume of reaction mixture we called Vt at the different time interval. So this volume of standard hypo solution required for titration at different time interval is corresponds to the amount of iodine liberated at the different time interval. As this one is the product, we can say that the amount of iodine liberated in our rate equation, we can say that this one must be the X, or again we can say that this one is the amount by which the reactant get reacted or consumed in the reaction. Now we require the initial concentration and the concentration after some time at the different time interval A minus X. The initial concentration we can find out by simply titrating the reaction mixture at the infinite time with the standard hypo solution. The volume of standard hypo solution required at the infinite time corresponds to V infinity, and hence this one is the volume of hypo solution corresponds to the total liberation of iodine after the completion of reaction. As this one is corresponds to the total liberation of iodine after the completion of reaction, this one we can say that corresponds to the initial concentration of the potassium persulfate, and hence we can say that the volume of standard hypo solution required for titration at the infinite time correspond to the initial concentration. Now we know that the initial concentration and the concentration by which the potassium persulfate reacted or the amount of iodine liberated, we can simply find out the concentration of potassium persulfate after some time t, that is A minus X. A minus X we can write in this way. A means V infinity and X means V t. Now we know the rate constant equation for the second order reaction. K2 is equal to 1 upon T X upon A into A minus X. Now put the values of A, X and A minus X in this equation and we get the rate constant equation for this reaction, that is reaction in between potassium persulfate and potassium iodide. So we can write the rate constant equation for this reaction. K2 is equal to 1 upon T. X means Vt, so Vt upon A means V infinity and A minus X means V infinity minus Vt. Now this equation we have to use for the determination of rate constant for the reaction in between potassium persulfate and potassium iodide. Now we have the numerical on the reaction in between the potassium persulfate and potassium iodide, and the numerical is given. The reaction between potassium persulfate and potassium iodide was studied at 25 degrees Celsius with following result. Show that the reaction follows the second order kinetics. In solution, we will start with the rate constant equation. So we have rate constant equation for second order reaction. And the equation is K2 is equal to 1 upon T into Vt upon V infinity into V infinity minus Vt. This one is the equation we have to use to determine the rate constant for the reaction in between potassium persulfate and potassium iodide. The result of this reaction was given is given in the form of this table. At the 10 minute, the volume of hypo solution required is 2.3. At 20 minute, the volume of hypo solution required 3.7. At 30 minute, it is 4.7. At infinite time, it is given 10 ml. Now the V infinity we can easily identify from this at the infinite time. So we write V infinity is equal to 10 ml. Now we will find out the value for rate constant at the different time intervals, means at 10 minute, at 20 minute and at 30 minutes. First, at time t is equal to 10 minute. At time t is equal to 10 minute, Vt is 2.3 and V infinity is equal to 10. Now put the values of V infinity and Vt in this equation. K2 is equal to 1 upon 10 into Vt 2.3 upon V infinity means 10 into 10 minus 2.3. By solving this, we get 2.3 upon 10 into 10 into 7.7. By solving this, 2.3 upon 770, and by solving this we will get 0.00298. This one we can write 2.98 into 10 raised to the power minus 3. Unit is minute inverse ml inverse. Okay. In the same way, we can find out the rate constant at time t is equal to 20 minute, Vt is equal to 3.7 and V infinity is equal to 10. So the rate constant K2 is equal to 1 upon 20 into 3.7 upon 20 into 20 minus 3.7. By solving this, 3.7 on 20 into now the rate constant K2 is equal to 1 upon 20 into Vt 3.7 upon V infinity 10, V infinity minus 10 minus Vt 3.7. By solving this, 3.7 upon 20 into 10 into 6.3 is equal to 3.7 on 1260. By doing this calculation, we get the value 0.00293. This one again we can write 2.93 into 10 raised to power minus 3 minute inverse ml inverse. At time t is equal to 30 minute, Vt is equal to 4.7 and V infinity is equal to 10. So the rate constant equation K2 is equal to 1 upon 30 into 4.7 upon 10 into 10 minus 4.7 equal to 4.7 on 330 into 10 into 5.3 into 5.3. By solving this, 4.7 upon 1590 and the answer is 0.00295, and this one we can write 2.95 into 10 raised to power minus 3 minute inverse ml inverse. By observing the values of rate constant at the different time intervals, we can say that the values are nearly constant and hence the reaction follows the second order kinetics.